Hello everyone, we're going to go over section 11.2, the parabola. I'm pretty sure you all know what the parabola graph look like. So let me just go over all of the important names that you need to know. So if you look at the picture below, we have this thing called vertex. It's going to occur either at a maximum or the minimum point on a parabola. And focus sits inside of the parabola. And the line segment joining 2 points which are directly above and below the focus on the graph is called the lattice rectum. The important thing that you need to know is the fact that the distance from focus to vertex is exactly the same distance from the vertex to the line directrix. If I call that distance A, then the length of the lattice rectum is going to be 4 times A. Let's just get straight to the point. So here's the same picture that you just saw. And let's look at the bottom part of it. Equation of a parabola. There are 4 of them. The first one, you guarantee that that parabola is going to open towards the right hand side. Equation 2, if you get equation 2, it's going to open left. Equation 3 opens up. And then equation 4 opens down. Now you're probably sitting there going, oh my gosh, how am I going to memorize all those formulas? Don't, because I'm going to give you that formula sheet when you take your exams. So take a deep breath and let's just start doing some examples. Okay, example 1, find the equation of the parabola with focus at 0, 4 and directrix is the line y equals -4. Graph the equation. To find the equation, I usually draw the picture first just to kind of get an idea of which way the parabola is going to be opening. Because if you know if it's going to be opening upward, then you know for sure that you're going to have to take equation number 3 and so forth. Okay, so now I'm going to give you a little rough sketch here. Okay, so focus at 0, 4, so 1, 2, 3, 4. Please always label your point. And then directrix is the line y equals -4. Okay, so this is our directrix. Now remember, the important thing is the distance from focus to vertex must be the same distance as vertex to the line directrix. So with that said, do you see that our center is going to be, not center, our vertex is going to be at 0, 0. Because from here to here is 4, from here to here is 4. So here we go. So we already got our vertex. The formula is given by h, k. This is going to be 0, 0. So h is 0 and k is 0. Let me label the vertex. Okay, so now can you tell which way the parabola is going to be opening? It's going to open upward because focus must sit inside of the parabola. So let me just jot that out. Okay, so if the parabola opens upward, look at the formula sheet, and we know for sure that we're going to have to use equation 3. Which is given by x minus h squared equals 4a and then y minus k. But we already know that h and k are both zeros. That means that we need to find the value of a. But remember, a was the distance from focus to vertex, same distance as vertex to the line of directrix. So the value of a must be 4. Okay, I think we're pretty much good to go. So let's just put it all together. So our equation is now x minus 0 squared equals 4 times a, which is 4 times 4, and then y minus 0. I'm just trying to show every single step here. So we have x squared equals 16 times the y. So this is the equation that we're looking for. So here is the answer. Now, just for heck of it, we're gonna find the lattice rectums, because so that way we can draw a more precise graph. Now, to find those points, you're gonna have to draw a straight line through the focus, and that line is going to be parallel to the directrix. So if I do that, then we're gonna get this line right here. Okay, so now that line is nothing but y equals to positive 4. So to find the lattice rectum, what you need to do is set y equals to 4 and then plug that 4 into that equation that we just got. Okay, I'll write everything out. So to find, I'm just going to denote it by LR. Set y equals to 4 and plug that into that equation. So then we're going to have x squared equals 16 times 4. So that implies that we're going to have x squared equals to 64, which means that x is going to be plus or minus 8. So therefore, our lattice rectum points, we're going to have it at positive 8, 4, and then negative 8, 4. So now let's jot those points. So here, this point right here, and the point right here is going to be our lattice rectum. So the parabola has to go through those 2 points. So let me write it as LR. This one is 8, 4. And this one's also LR at negative 8, 4. Let's draw the graph. You know my graphing skills. I don't have any. Oh my gosh. You get the idea. Alright, so that is the graph of x squared equals 16y. Okay, let's do another one. Find an equation of the parabola with vertex at negative 2, 3 and focus at 0, 3. And we're going to have to graph this. So let's jot some points just to get an idea of what the graph's going to look like. So the vertex is at negative 2, 3. And the focus is at 0, 3. So can you tell already which way the parabola is going to open? Remember, focus must sit inside of the parabola. So in this case, the parabola is going to open towards the right. So let me just make myself a note of that. So that means that if you look at the conic sheet, we're going to have to use equation 1. Alright, so which is y minus k squared equals 4a and then x minus h. So let's keep that in mind as well. Now remember that a is the distance from the vertex to focus, which is same thing as the distance from the vertex to the line directrix. So that means that our a must be 2. Because from here to here is 2, that means from here to here must be 2. And the directrix is going to look something like this. It's going to work? Yep. Alright, so this is our directrix. In this case, it's going to be at x equals negative 2, negative 3, negative 4. Alright, now let's write down what we got. So we already got the a equals to 2 and the vertex. The formula for that is always h, k, but that was given to us, negative 2, 3. So our h is going to be negative 2 and k is going to be 3. Now let's plug these values into our equation. So we're going to have y minus k, which will be 3, squared equals 4 times a And then here you're going to have x minus minus 2. So our equation is going to be y minus 3 whole quantity squared equals 8 times x plus 2. So this is the equation that we're looking for. Now to graph it out, we're going to have to find the latus rectum. So let's do this. To find it, you're going to have to draw a straight line through the focus, and that line better be parallel to our directrix. So in that case, to find, I'm just going to denote it as LR. We're going to have to set x equals to 0 and then plug that value into the equation that we just got. So we're going to have y minus 3 whole quantity squared equals 8 times 0 plus 2. So that implies that y minus 3 squared equals, what is that, 16? So that implies that y minus 3 equals to plus or minus square root of 16, which is plus or minus 4. So that implies that either y equals 4 plus 3 or y equals negative 4 plus 3. So in this case, we're going to have 7 and negative 1. So therefore, our latus rectums are, what was the x value? 0, 7, and 0, negative 1. So let's plot those points. 3, 4, 5, 6, 7. So this is LR. And this is also LR. Okay, so finally we could connect those dots and draw our final graph. And here we have it. Example 3, find the vertex, focus, directrix, latus rectum, and graph. Alright, so let's take a look at this equation here. So this is of the form x minus h squared equals 4a and then y minus k. Alright, so which equation is that? We're going to have to use equation 3. Now let's write down our formula for vertex. Is h comma k, so in this case we're going to have 2 comma 3. Alright, now the next one is focus. Formula is h comma k plus a. Aha, so now we're going to have to find the value of a. Alright, so let me just go 2 comma and then 3 plus a. Alright, so let's take a look at this. Now if I look at the equation, we're going to have 4 better equal to 4 times a. So that means the value of a must be 1. Okay, so with that said, this is going to be 2 comma a is 1, so 2 comma 4 is going to be our focus. Now let's go with the directrix. The formula is it y equals k minus a? So that implies that we're going to have y equals 3 minus 1. So the y equals to 2 is going to be our directrix. Okay, let's graph this out. Alright, so vertex is at 2 comma 3. And focus is at 2 comma, where are we? 2 comma 4. So that means, of course, the parabola has to open upward. And the directrix is y equals to 2. Okay, now you know what to do. We're going to have to find the latus rectum. So let's do that. So if I have to draw a straight line through focus, that line is y equals to 4. So to find lattice rectums, we're going to have to set y equals to 4. Then we're going to have x minus 2 squared equals 4 times 4 minus 3. Alright, so that implies that x minus 2 is going to be plus or minus square root of 4. So it's going to be plus or minus 2. So that means x is going to be 2 plus 2. Or x is negative 2 plus 2, which is going to be 0. So therefore, our LRs are 4, 4 and 0, 4. Plotting those points, so this is 4, 4. Sorry, focus. I'm just going to write over you. And then 0, 4. Let me just rewrite the focus. Focus was what, 2, 4? Now connect those dots. Draw out the graph, and we're done. Let's do another one. Find the vertex, focus, directrix, lattice rectum, and graph. So now we're given x squared plus 4x minus 4y equals to 0. Now, in order for us to find the vertex and focus and such, you need to complete the square to make this equation into a standard form. So let's do this. We're going to say complete the square. So what I'm going to do is I'm just going to rewrite. We're going to have to complete the square on the x, obviously. Okay, so I usually divide this number by 2. I meant not usually, always. And then what goes in here is 2 squared. Oh, sorry, 2 squared is 4. If I'm going to add in the 4, I'm going to add the 4 on the other side. So now this whole thing becomes x plus 2 whole quantity squared minus 4y equals to 4. To make it look like one of the formulas that we have on our conic sheet, let's bring the minus 4y on the right hand side by adding it. Alright, so almost look like it. So we need to factor out the 4. Okay, so this is our equation in standard form. Now from here we should able to find the vertex, focus, and so forth. So let's look at the formula sheet. Now this is of the form x minus h squared equals 4a and then y minus k. So which equation is that? Is it equation 3? So let's go with the vertex. Is h comma k. So in this case we're gonna have negative 2 comma negative 1. And our focus, what's the formula for that? H comma k plus a. So you're gonna have negative 2 comma negative 1 plus a. Sorry, I forgot to compute the value of a here. So our a, how do you find that is what? You better have set 4 equals to 4a. That implies that our a is going to be 1 again. So here you're going to have negative 1 plus 1. So here you're going to have negative 2 comma 0. So that's going to be our focus. And what's next? Directrix. So in this case, we're going to have y equals k minus a. So that means y equals negative 2. It's going to be the line of directrix. So let's sketch this out and see what we get. Okay, so the vertex is at -2, -1. And focus is -2, 0. I hope you can see that. And then the directrix is the line y equals to -2. And now let's find the lattice rectums. If I draw a straight line through the focus parallel to our directrix, that line is y equals to 0. So what we need to do is to find the lattice rectums, set y equals to 0. Okay, so we're going to plug that into this equation. Then we're going to have x plus 2 squared equals 4, and then 0 plus 1. So x plus 2 is going to be plus or minus square root of 4, which is 2. So our x is going to be either 2 minus 2 or -2 minus 2. So this is 0 and -4. So therefore, lattice rectums are at 0, 0, and then -4, 0. Okay, so and -4, 0. Now connect those dots from the vertex. And we're done. How are you guys feeling in this section? Hopefully you're getting kind of hang of it, because next topic is we're going to be learning about ellipse. Anyways, if you have any questions, please let me know.